Hello. In this course, I'll show you how to profile an application in Pharo. That means measuring the execution of expressions to see if we can replace them with others to gain time during the execution of a program. Basically, what people say is, if you've never profiled an application, you could increase speeds by 40 to 50%. I'm not convinced. I don't know. I've no proof. But I can show you the tools in Pharo for doing this profiling. The first expression in Pharo is time to run. It's a message we send to a block, which will give us the runtime of an expression. So, here in 1000 factorial, I want to measure the runtime of 1000 factorial. I put it in a block, and I send the message time to run. Now that we have time to run, it's easy to compare two executions. Here's a little exercise. If I do select followed by collect, is it slower than select then collect? Knowing that this involves two passes in the first case and one in the second, so I think it will take longer, but we're going to check. What do? I create my collection in both cases. I'm looking. I create my collection with 10 elements, a small collection, and what I'll do is create a certain number of times. I'll make a loop so I can run the expression several times. You can see in the first part, I've my collection. I select every element larger than 5. And afterwards, I'll square the elements I've selected. And in the second expression, I'll say, what do I want to select? Everything larger than 5, and I'll square them. We see that the system tells me that's 500 milliseconds, and that's 300 milliseconds. The second expression is better. You see how it works. It's up to you to do it. Note that we're sometimes obliged to put very large loops inside to amplify the measurement for both cases, of course. Otherwise, there's another operation, another message called bench. Bench will tell us how many times the code which is being studied is executed over 5 seconds. I take my 1000 factorial bench example again, and I can execute it 610,000 times a second. In this case, if we so desire, we can also make it that the figure is as high as possible. There's also a variant of bench, bench 4, where you can specify the size. What's interesting to see is that 2 seconds, it's really the second message, which is sent to message 2, which will give us a duration, an instance of the duration class, and which will control how long the system runs. This shows you once again that everything's an object in Pharo. I set the seconds at 2 seconds. I send the second message to object 2. What you have next, there's also what we call a profiler, which is sampling based. What will happen is you'll execute your program, and it will go at regular intervals to inspect the execution stack, see what's in the stack, and collect information. So how do we bring it up? We do time profiler spy on, and we'll pass it a block. I want to repeat 20 times that I'll show on the transcript 1000 factorial, which I convert into a string, which usually costs the most. After that, the profiler will give us this kind of result, with a tree showing us the branches amongst which we've spent most time. It shows us we spent 63% of the time in the method printOnBase. It's just to show you it's there. There's a profiler you can play with if you're interested. So to summarize, to begin with, you can use time to run, bench, and the profiler. There's a chapter in the book Deep into Pharo showing this kind of optimization technique. I just wanted to point out, as you see in these 3 examples, we always use blocks. This is a block. This is a block too. Why? You saw in the course on blocks that they allow you to freeze the expression. The definition of the block doesn't execute and give bench the possibility of controlling the number of executions, or deciding when execution of the program will begin. The other thing I'd say is, find out about how time to run and bench are implemented. To do that, you click on Expression and do Browse or Implement, and you'll see the code.